Welcome to the channel, glad to have you here. Today, we're talking about FRBs and related topics. To talk about them, you kinda have to know what they are. So, FRB is an acronym standing for Fast Radio Burst. FRBs are brief, energy-filled bursts of radio waves. A radio wave is a form of electromagnetic radiation, or light energy that can't be seen by the naked eye. FRBs can emit the same amount of energy in a few milliseconds as our sun can in 3 days. Imagine sitting out in the sun for 3 days, not experiencing night at all, and then condense that into less than a second. Ouch. Luckily, radio waves can't penetrate or affect the human body. They also act on strict cycles, believe it or not. Well, how can we even understand what these FRBs are doing if we can't see them, you ask? I hope. Either way, I have an answer to that. Since FRBs are a type of radio wave, radio telescopes are used to detect them. Do any of you guys remember what these things are? Yeah, that's a radio telescope. Essentially, how they work is they catch the radio waves in the concave dish and direct it to the center. Kinda like how glasses work. The lens curves the light to focus it where it needs to be. However, the lens here is the massive dish of a radio telescope used for astronomical discoveries. Okay, so I know what you're all thinking. Maybe. Why do we need to know this at all? It's just a spurt of energy. Well, that, my friends, is where you're wrong. For a long time after these FRBs were first discovered, many thought they were communication from some other entity, like an alien or a religious deity. That is where they were wrong. We have managed to find the source of one of these FRBs, since they travel in straight lines, it being a magnetar. Well, what's a magnetar? I'm glad you asked, definitely not just me with a different voice. A magnetar is an extremely magnetic neutron star. Well, what's a neutron star, and how do we know it's magnetic? A neutron star is a star that came from a massive star undergoing a supernova, or implosion. However, this star was still a bit too small of a mass to become a black hole. Now, how do we know that a magnetar is magnetic? I'll be right back. Alright, we're back. So, we know that a magnetar is magnetic due to this special little device called a Gauss meter. A Gauss meter detects magnetism through the push and pull of electrons situated in the semiconductor, which produces a voltage that is directly related to magnetism. This relation is explained by the connection discovered that electric forces and magnetic forces are interconnected in what's known as electromagnetism. That term may or may not sound familiar to you. I hope it does, though. The electromagnetic spectrum is alterations in the electric and magnetic fields. Ta-da! Full circle, people. So, to pull this all together, we have some FRBs being caused by magnetars. These radio waves are detected by giant satellite dish-looking things known as radio telescopes. We also discovered magnetars through this little thing called a Gauss meter. Cool. Well, why? Why did you just spend around 5 minutes listening to me essentially rant about this? Here's an idea for you. We found that these radio waves weren't from aliens or proof of some religion over another. But why is this relevant in the slightest? Not all of the sources of FRBs have been discovered, and we're still looking for their other sources. By looking for the how and why surrounding the FRBs, we can learn more about our world that we live in, like what happens when the universe's electromagnetic waves redshift or stretch so far that they aren't waves anymore. These could help solve the question of what was before the Big Bang all those years ago, although nothing is certain. It's similar to how at least 75% of the ocean is undiscovered, but in space that number is closer to 90 or even 95%. There are many answers and questions that can come out of the continuation of this topic that I can't quite provide right now. Trust me, I tried. One example of a possible outcome could revolve around why magnetars are so magnetic, but it also could not lead to that. The future surrounding space is rather rocky and unpredictable, as the laws of physics and existence that are commonly accepted is quite often flipped on its head. Okay, that's enough brain hurt for one day, yeah? For those viewers out at home, comment down below whether or not I should continue this as a series and any questions you might have. For those watching this as my school presentation, do you guys have any questions? I'll try my best to answer.